I'm going to go ahead and run through a few examples of how to integrate Python and D3. So this is a package called MPLD3, which I think kind of does one way of integrating them very tightly. So the way MPLD3 works is it connects Matplotlib, the Matplotlib package itself, to D3, right? And the way it does that is it actually deconstructs the Matplotlib backend API that we talked about. So it goes in and looks at the different layers of the Matplotlib graphic and re-renders those in HTML and D3. And it does this inside of a Jupyter notebook. So I want to run through an example of how to use MPLD3. So it's pretty simple. This is kind of our standard import and load, and then we also just add MPLD3, so we can run that. And then you can define different CSS's style sheets to give the MPLD3 specific styles that you want. And then here's the chart we're going to make. So this is a basic scatter plot where here we're just defining 3 random variables, normally distributed. And for each of those, we'll define a label, and then we'll just go ahead and do a simple plot, right? So we'll just do a scatter plot with X and Y, right? We're using circles. We'll make them blue, and this is what we're left with. So to connect this to MPLD3, there's just a couple commands that need to be run. So just the tooltip uses their plugin tooltip, and there's other tooltips. This is just one example of a thing you can do with the tooltip. And then you connect that. So connect it to the figure object and display it using MPLD3, which will give you the interactive version. So I'm going to go ahead and run this. It takes a second to run. And here's the chart that we had. We have a bunch of blue circles, and we get the tooltip from MPLD3. So this tooltip syntax was defined here, where here we created this label, right? We give it columns, and we appended the label as an HTML itself, and then we styled it in the CSS. So we went ahead and gave a style to our tooltip. So we define this tooltip entirely above, and we can go ahead and interact with our data. On all charts that are rendered by MPLD3, it gives you a little bit of interactivity, similar to the way that Matplotlib gives you interactivity. Anyway, you can do a pan, right? You can jump home, and you can zoom in on a section of the graphic. So those are all enabled. And there's other plugins as well that are available from MPLD3, and you can check those out. I think you can add some quick interactivity for a graphic. And I feel like this does help for exploratory data analysis in Python, because sometimes it's helpful to see a little bit more about your data. Row 16 might be something that means a little more. Really what I wanted to talk about was getting D3 inside of Python. And they actually did this in MPLD3. So I wanted to kind of use this as an example to show how they accomplished it. So the Jupyter notebook itself uses require.js, and to load D3 into that web page, we actually want to load D3 into this web page. We can actually pass in some HTML. So we can actually pass in HTML and render it inside the notebook. So there's a endpoint to do that within Jupyter. And here is their simple HTML. So this is the most basic way you could do it, right? Where you're defining a whole HTML. Here you load the scripts. So your D3 and MPLD3 URLs, they could be both local or hosted. And then use a template to define the whole graphic in HTML, CSS, and JavaScript, and then you dump that into the browser. So what this does is it builds out the graph like that and then dumps that into the browser using, like Jupyter has a function called HTML, which will dump these things in. And Jupyter uses require.js, which is what I mentioned earlier. And so the other way to do the same graphic is to use require. And require here, you set a config path for libraries. It's a library management system, or actually a dependency management system for JavaScript. And here, this gives you D3 accessible. So this is a little more complicated to do, but I find it's generally a little more reliable. So this works within the notebook. So that's what this is for. In the notebook, we're seeing this code using require JavaScript. So this is the tricky part to get D3 loaded. And they also, so they did a really clean job of implementing this. So you can look at their code here. And also, PyD3 is just kind of another example of a package that connects D3 and the Jupyter notebook. So it does it in the same way by loading it from within the HTML. And I'll just give a quick example of kind of what you can do here. The starts, you can just load this extension. You have to pip install it. And then by declaring D3, this is called block magic, it'll make this whole cell render within this context. So we can do that, and this will render all as HTML with D3 available to us. So what it does is it takes this, the D3 function that's defined by this extension, takes this code, injects it in a place where D3 is available through require.js, and then we can go ahead and use D3. So this is the bar chart example from Murray's text. And we can go ahead and render this right in a notebook. So I think this is a pretty slick way to work with JavaScript directly. And you can interface this by even exporting data from Python, doing some visuals in D3 this way if you like. That's how to integrate it. And so basically there's a couple packages that do this for you pretty well. And I recommend both of these to play around with that.